So one of the questions we get a lot is around voltage distortion. And why is voltage distortion bad? For example, if multiple zero crossings exist from harmonics, is that a bad thing? And what can I do about it? So we've talked about multiple zero crossings with voltage distortion and talked about how that causes misoperation. The specific things that we like to talk about with multiple zero crossings are things like sine wave distortion causes things like digital clocks to misoperate. So we actually heard a story about digital clocks misoperating where the workers got to go home early. So I guess in some cases maybe it's not a bad thing. But in some cases like welding applications and other things, it could be a real problem. And so what we're going to show you here is an example of multiple zero crossings and what that really means in terms of the voltage waveform. So let me turn on the meters and we'll put on some loads and I'm going to show you what it looks like. So if we look at this voltage waveform on top and the current waveform, you can see that the current is distorted, causing voltage distortion. So now I'm going to go just to the voltage to show you again that the current distortion causes voltage distortion. But if we make the voltage distortion significantly worse, we can see where those multiple zero crossings occur. And if we have that happen, some equipment that's synchronizing based on normal 16.67 milliseconds per cycle, 2 times the voltage crosses zero, that's not normal in this case because what's happening is we're getting a lot more crossings. So we turn that off. And now I'm going to show you when I describe that a little bit in terms of the camera here, I'm going to draw a picture of what that would look like. So if I have a normal sine wave, okay, and again, this is a 60 hertz sine wave, and 60 hertz means that the time between here and here is 16.67 milliseconds. And so, and that's, by the way, 1 over 60. So, if we want to say that that's normal, but yet we have another situation where the voltage crosses zero, let's say a couple times here, and a couple times here, and maybe even a couple times here. And so it crosses more frequently. Well, the timing circuits now say, oh, this is one cycle, and oh, here's another cycle, and here's another cycle, and so forth. So, in fact, time moves a lot faster. So things like welding applications and anything that uses a digital clock, PLC control, all of those kind of things now become potential problems. So, is voltage distortion a problem? Yes, it can be. But what does it cause? It causes misoperation. Why does it cause misoperation? Mostly from the notching of the voltage waveform that causes either multiple zero crossings or distortion around that 0 point that makes it look like it's not 60 hertz. One of the things that we've seen specifically is transfer switches because it thinks a source on this side has 60 hertz and a source on the other side might have, with the notches and the multiple zero crossings when you're loaded with harmonics, like drives and other things, might have a frequency that looks like much higher, 180 hertz. Well, of course, it's not 180 hertz, but it's 60 hertz voltage with multiple zero crossing and notches. And that's really the concern. Again, misoperation from voltage distortion.